Okay, so hello everyone. So in this video, I want to do a systems of three equations by substitution. I did try to make a video earlier, like just now, but I messed up. Yeah, this method is like really tedious. You have to be really careful. I'm gonna try to go as slowly as I can, only because, yeah, this method, it takes a lot of practice and it takes a lot of patience to master. So if you're overwhelmed with this method, you're not the only one. You know, it's one that is not, like, even for me, that I know how to do these problems, it's still something that I kind of mess up on a little bit. But you know, the idea is that as long as you understand, like, how it works, you know. So basically, we have a systems of three equations, obviously. 5x plus 4y plus 3z equals 52. 2x plus 2y plus 6z equals 52. And 6x plus 4y plus 2z equals 48. And let me make sure that I just... Okay. So the idea here is that you have to solve for a variable on one of these equations. Usually, they always choose the first equation, which is what I'm going to do. So, and, you know, again, if you don't like working with fractions, I'm going to show you a way to, like, you know, to make sure that you know, that, I mean, obviously, when we solve for x, because I'm going to solve for x, it's going to be a fraction, but once we plug it in to the other two, I'm going to make it so that they're not fractions. Okay, so basically, we have 5x plus 4y plus 3z equals 52. I'm going to solve for x, so to solve for x, we're going to subtract 4y and 3z on both sides. And if you want to split your, like that, so basically we have 5x equals 52 minus 4y, and let me, minus 3z, right? We divide both sides by 5, and I'm going to keep it as a fraction, okay? It's going to be x equals 52 minus 4y minus 3z all over 5, okay? This is going to be new equation 1. So once I plug this into the other two equations, I'm going to rewrite the system so that you guys understand what exactly happened, okay? This is going to be the new equation that we're going to use for the first one, okay? Now, we're going to plug that in for equations 2 and 3. However, I'm going to use a little trick so that basically you don't have fractions at all. It makes the problem longer, but trust me, it makes it easier, because that way you're not working with fractions. If you don't like working with fractions like me, you know, it makes the problem easier. So we have 2 times 52 minus 4y minus 3z all over 5, right? Because we're plugging that in for x on the second equation, okay? So, and then plus 2y plus 6z equals 52. Now, basically, here, what's going to happen is that, so I'm going to go step by step. I'm going to plug in this, you know, plug in 2, right? I have 52 times 2, which is 104, and then minus 8y minus 6z all over 5 plus 2y plus 6z equals 52. Now watch what I'm going to do. I'm going to multiply this entire part by 5 and do the same thing to the other side so that the fraction will cancel out. The fraction cancels out on here, but on here it's going to be, so we have 104 minus 8y minus 6z, and then we're going to multiply 5 to the 2y plus 6z. So we're going to have plus 10y plus 30z equals, and then 5z, or I'm sorry, 52 times 5, not 5z. 52 times 5 is, I think it's 260. Yeah, 260, right? So now the idea here is to combine like terms. We have negative 8y, negative 6y, and also, hold on. Okay, hold on. We have and then it's going to be plus 10y plus 30z equals 260. Okay, what I was saying was we have negative 8y and 10y, and also negative 6z and 30z, right? Notice that we have a constant here, but give me 1 second. I'm gonna go ahead and simplify this first. So we have minus, so negative 8y plus 10y is 2y, right? Negative 6z plus 30z is 24z. And then 260, you know, basically we have make it equal to 260. So the idea here is that we don't want a constant on the left side. We never want a constant on the left side. So we're going to subtract that, right? Minus 104. 2y plus 24z. And we subtract this out. We get 156, right? So let this be new equation 2, okay? And like I said, guys, this is really long. It's a very tedious method. So then we do the same thing for the third one. We're going to plug in x. We're going to plug in for x, right? We have 6, so 6x plus 4y plus 2z equals 48, right? We're going to plug in x again, right? So we have 6 times the quantity, 52, minus 4y minus 3z, all over 5, and then just write the rest of it. So plus 4y plus 2z equals 48. So then, again, you're going to go ahead and, so first we're going to multiply the 6, right? Let's see here. So 52 times 6 is 312, right? So we have 312 minus, and then 6 times 4 is 24, so 24y minus 24y minus 18z all over 5 plus 4y plus 2z equals 48. Now, notice what I'm going to, pay attention to what I'm going to do. Like the other problem, I am going to eliminate, or not eliminate, I'm sorry. This is substitution, not elimination. So I'm going to multiply, so I can cancel out the fraction. I'm going to multiply this whole thing by 5. And what I do to the left side, I do to the right side, times 5 here as well. So I'm going to do, obviously, because this is a fraction here, you're just going to put the numerator, you're going to put the top number. So basically, when you do this, it'll cancel out. So you're going to have 312 minus 24y minus 18z plus 4y plus 2z. Oops, and again, I almost made a mistake. This is the same, so the numerator is the same. However, you're also multiplying this 5 to the 4y plus 2z, right? So it's going to be plus 20y plus 10z equals, and it's going to be 48 times 5, which is 240. So now it's a matter of combining like terms, cleaning it up a little bit. We have 312, and then we have minus 4y minus 8z equals 240, right? The way that I got that was obviously because negative 24y plus 20y, and then negative 18z plus 10z. You can always rearrange it so that, you know, you have like 312 minus 24y plus 20y minus 18z plus 10z. Like, you can rearrange it so that the variables are next to each other, if that's how you like to do it. But if you can do it in your head, that's great. So yeah. So now at this point, all we have to do is subtract 312 on both sides. Because again, we don't want a constant on the left side. We never want a constant on the left side. So it's negative 4y minus 8z is equal to, and 240 minus 312 is negative 72. So now let this be new equation 3, right? So this is new equation 3. Now let's rewrite this system. We have new equation 1. So let me just highlight the equations we have. We have new equation 1. This is new equation 2. And then this is new equation 3. So we're going to rewrite them. So basically, what we have is this. We have x equals 52 minus 4y minus 3z all over 5. (52) minus 4y minus 3z all over 5. And then we also have equation 2, which is 2y plus 24z equals 156. And then we also have negative 4y minus 8z equals negative 72. Now, this is how the systems of equations looks. However, notice here that we have a systems of 2 equations now, because really, you know, this is just extra. We already used this, so we don't need it anymore. We don't need that anymore. We already used it. So basically, we just have a systems of 2 equations. Now, because this is elimination, we have to do it by elimination. Or, I'm sorry, because this is substitution, we have to do it by substitution. Excuse me. So we're gonna go ahead and solve for one of the variables. So if we have 2y plus 24z equals 156, we basically subtract 24z on both sides, right? We have 2y equals 156 minus 24z. And we divide both sides by 2. Doing so, that will give us, I think it's 70, is it 78? It's going to be 78, so y equals 78 minus 12z. Now go ahead and plug this in for this part here. So now we have -4 times the quantity 78 minus 12z minus 8z equals -72. Using distributive property, what is 78 times 4? We have -312, and then 12 times 4 is 48. So plus 48z minus 8z equals -72. Now, again, we never want a constant on the left. So we're going to go ahead and get rid of that constant. We have 48z minus 8z equals, and again, 312, so -72 plus 312, that's 240. So then this is going to be 40z equals 240. So now 240 divided by 40, that's going to be 6. Because we divide by 40 on both sides. So z equals 6, okay? Now once you have solved for one of the variables, everything becomes easier. We already have y equals 78 minus 12z. So y is going to be equal to 78 minus 12 times 6. So we have 78 minus 72 is equal to y. So y equals 78 minus 72, that's going to be 6, I believe. Y equals 6. And now for x, we did solve for x, which, I mean, I did say that we didn't need this one anymore, but that was because we were doing systems of 2 equations. I mean, you can always plug it, like do 6x plus 4y plus 2z, like plug in y and z and solve for x that way, but because we already solved for x at the very beginning of this video, we can use that to our advantage. X equals, it was x equals 52 minus 4y minus 3z all over 5, right? So, we're going to use that. So, (52 minus 4y) and then minus, give me 1 second, guys, minus 3z all over 5, right? So then it'll be x equals 52 minus 4 times 6 minus 3 times 6 all over 5. This is really just x equals 52 minus 24 minus 18 all over 5. And if you put that in your calculator, so 52 minus 24 minus 18 all over 5 you come up with x equals 2. So the solution to this systems of 3 equations is x equals 2, y equals 6, and z equals 6. And if they want it as an ordered triple, again, an ordered triple is x, y, z, so it would be 2, 6, 6. And this is your final answer for this problem here. Okay. So I hope that helps, guys. I know this method is really tedious, and it is something that, you know, even I mean, honestly, I do hate doing this method because it's like really, really long. It takes a long time. Obviously, you know, because I'm teaching it on here, it takes me a long time because I have to explain it. But, you know, if you do it on your own, like if I did it on my own, it wouldn't take as long. But yeah, so I hope this helps, guys. Please let me know if you have any questions. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.